Hello and welcome back to the deep dive. We are right in the middle of revision season, and today we're opening up the NSERT textbook to Unit 10, Biomolecules.
Good to be back.
We're tackling a topic that, students often think is just general knowledge, but then they end up losing some very silly marks on it in the board exams.
You are absolutely right about that. We are looking at vitamins.
Yeah.
And let me tell you, do not underestimate this section.
Yeah.
Everyone thinks they know vitamins.
Yeah, because their grandmother told them to eat carrots for their eyes.
Exactly that. But the chemistry of it is actually quite precise.
Okay, so before we get into all the structures and deficiencies, I want to start with a question. I actually got this from a student yesterday. It's crunch time, exams are coming up. And he asked me, "Sir, if vitamins are essential and they help with energy, if I take, say, 5 times the dose of a multivitamin right before my exam, will my brain work 5 times faster?"
I love that question.
Right.
Because it hits the single biggest misconception about this entire topic. The short answer is no. Absolutely not. If you take 5 times the dose, the best case scenario is that you produce some very expensive urine.
Expensive urine. Okay, that's a phrase to remember.
It is. Your body just flushes out the excess. But the worst case scenario, if you overdose on the wrong kind of vitamins, you're not just wasting money. You could actually be creating toxicity.
Poisoning your own system.
Yes, you can poison your own system.
Which is the last thing anyone needs during their programs. So the goal of this deep dive is to unpack exactly why that happens chemically. We'll cover classification, the mechanism, and of course, the deficiency diseases you need for the exam.
Perfect. So let's start with the absolute basics. A 1-mark question in Section A. What is a vitamin? What do you write?
I feel like most students would write something like small organic things in food that keep us healthy.
And they would probably get half a mark for that, maybe 0 if the examiner is being strict. It's a layman's definition. For Class 12 chemistry, you need precision. You have to hit 3 key points.
Okay.
1, they're organic compounds. 2, they're required in very, very small amounts. Minute amounts.
Right, like micrograms.
Exactly, micrograms or milligrams. And
Yeah.
3, most of them cannot be synthesized by the human body. They must come from our diet.
Okay, organic compounds required in minute amounts. That separates them from carbs or fats, which we need in grams, and from minerals like iron, which are inorganic.
Precisely. Now, here's the concept that really connects the biology and the chemistry. Why do we even need them? They aren't fuel. This is so important. Vitamins do not provide energy.
Wait, let's pause there. That's a massive point.
It is.
Because every energy drink ad implies they do. So if I eat a spoonful of sugar, I get energy. If I eat a spoonful of pure vitamin C, I get, what, 0 energy?
0 calories, 0 energy. Carbohydrates and fats, they are the fuel. Vitamins are the coenzymes.
Coenzymes. Okay, let's break that term down. Enzyme is a word we hear all the time, but coenzyme sounds a bit more technical.
Well, think of an enzyme. We know they are biological catalysts. They speed up reactions. But many enzymes are, synthesized in an inactive form. They're called apoenzymes. They're like a complex machine that's fully built, but it's switched off.
Okay, so the apoenzyme is the machine just waiting to work.
Correct. And to turn it on, it needs a little helper molecule to bind to it. That helper is the coenzyme. And very often, vitamins are these coenzymes. When the vitamin binds to the apoenzyme, the whole thing becomes a holoenzyme. That's the active form.
So the formula is basically apoenzyme plus the vitamin equals the working holoenzyme.
That is it.
We had an analogy for this that I really liked, the power tool one.
Right. Imagine an electric drill. The drill itself is the enzyme. It has the motor, the gears, everything. It has the potential to do work. But if it's a cordless drill with no battery, it's just a heavy paperweight. It can't do anything.
And the vitamin is the battery.
Exactly. You slot the battery in and suddenly the machine comes alive. It can do its job. The battery doesn't become the hole in the wall. It just enables the tool to work.
That makes the whole energy confusion so much clearer. And to take that analogy further, if you have 1 drill, you only need 1 battery. Having 50 extra batteries sitting around doesn't make that 1 drill spin any faster.
That's it. That brings us right back to the expensive urine idea. In biochemistry, we call this saturation kinetics.
Saturation kinetics.
Yes. Once all your enzymes, all your drills have a vitamin attached, adding more vitamins does absolutely nothing. The active sites are all full, they're saturated.
That is such a clear way to see it. So chemically, when we say vitamin B3 helps with energy, it's not burning. It's actually part of NAD plus DO, right?
Yes. Nicotinamide adenine dinucleotide, NAD plus BES. It's an electron carrier. It just moves electrons around during respiration. Without the vitamin B3 part, The enzyme can't hold on to the electrons. The whole metabolic process just stops.
So you have the fuel, the glucose, but the spark plug is missing.
That's a great way to put it. The spark plug is missing.
Which brings us perfectly to classification. This is probably the most frequent question area for the boards, isn't it?
Absolutely. We divide them into two groups based on one simple property: solubility. This isn't just trivia. It dictates how the vitamin behaves in your body. So group 1, fat-soluble vitamins.
Yeah.
Group 2, water-soluble vitamins.
Let's do fat-soluble first. These are vitamins A, D, E, and K.
The mnemonic is easy.
Hmm.
AD. These vitamins dissolve in fats and oils. Because of that, they get stored in the body,
Where?
specifically in the liver and adipose tissue, which is just your body fat.
Stored is the key word there. So because we store them, we don't need to eat them every single day, right?
Generally, yes.
Sure.
Your body keeps a reserve. But, and this is a big but, because they are stored, they can accumulate. If you take massive doses of vitamin A or D, they build up to toxic levels.
Oh, right.
This condition has a name. It's called hypervitaminosis.
So the toxicity risk is mainly with the fat-soluble group AD. That explains why you can actually overdose.
Correct.
Hmm.
It can cause some serious issues: liver damage, hair loss, joint pain. Now, contrast that with the water-soluble vitamins. That's the B complex group and vitamin C.
Just B and C.
Right. Since they dissolve in water, they circulate freely in your blood. But here's the catch. Your body can't really store them. Any excess is just filtered out by the kidneys and...
Excreted in urine.
Exactly. Back to the expensive urine.
So you can't build up a reserve of B and C.
Not really.
Yeah.
Which means you need to supply them regularly in your diet, almost daily. And it also means toxicity is very, very rare because you just pee out any excess.
Okay, let me just recap this for the exam. Fat-soluble is 80K, stored, so risk of toxicity. Water-soluble is B and C. Excreted, so we need a regular supply. But
I feel like there's an exception. Chemistry always has an exception now.
you are definitely ready for the board exams. Yes, there is one major exception you must know. Vitamin B12.
B12, okay.
Even though B12 is water-soluble, it is stored in the liver in significant amounts. It's the only water-soluble vitamin that the body actually holds on to. That is a classic trap question in exams. Noted. B12 is the rule breaker. It's water-soluble, but it's stored.
Before we move on, I want to just quickly touch on the history because it explains the name itself. Vitamin. It sounds like vital amine.
Oh, that's where it came from, isn't it?
Yes. In the early 1900s, a scientist, Casimir Funk, he isolated a compound from rice husks that cured a disease called beriberi. Chemically, it had an NiNH2 group, so he called it a vital amine.
But then they found out that not all of them are amine.
Exactly.
Right.
Vitamin C, for instance, is ascorbic acid, no amine group. Vitamin A is an alcohol. But the name vitamin was just so popular, they just dropped the E from the end and kept it.
I love that. Basically, we were wrong about the chemistry, but the branding is too good to change.
Pretty much.
Speaking of chemistry, let's talk about a reaction. The syllabus mentions the antioxidant property of vitamin C. There's a lab experiment for this with potassium permanganate.
Yes, KMNO. This is a practical you might have seen.
Yeah.
KMNO is that beautiful, deep purple solution. It's a very strong oxidizing agent.
Right.
So if you take a beaker of this purple KMNO and you add a source of vitamin C, say, some lemon juice, some quite dramatic happens.
What happens?
The color just vanishes. It goes from deep purple to colorless.
Wow, just like that. It's like a magic trick. Why does the color disappear?
Because vitamin C is a reducing agent. It donates electrons to the permanganate. The purple MnEO ion gets reduced to MnO, which is colorless.
So the color disappearing is visual proof that vitamin C is fighting oxidation.
That's it. And in your body, it does the same thing. It fights these things called free radicals, which are oxidative molecules that damage your cells.
Yeah.
Vitamin C just sacrifices itself to neutralize them.
That is a great mental image. It's a sacrificial shield.
Okay.
Okay, let's move to the second half. This is where the marks are. Deficiency diseases.
Yes.
You can't just say vitamin A is good for eyes. You need the specific disease name.
Specificity is everything here. Let's run through the most important ones for Class 12. We can group them to make it easier.
Let's start with the B complex. There are a lot of Bs. Which ones matter most for the exam?
Okay, you should focus on B1, B2, and B12. Vitamin B1 is chemically known as thiamine,
Thiamine.
and its deficiency causes beriberi.
Beriberi. What are the symptoms of that?
It affects the nervous system and muscles. So think severe muscle weakness, even paralysis. It's really a failure of energy metabolism because remember, thiamine is the spark plug for burning carbs.
Got it. B1 is thiamine, causes beriberi. What about vitamin B2?
B2 is riboflavin, and this deficiency causes chelosis.
Tylosis, that's the cracking of the lips, right?
Yes, specifically fissures at the corners of the mouth and also some digestive issues. If you see a question about fissures at corners of mouth, you write vitamin B2.
Okay. And then the rule breaker, B12. What's its chemical name?
Cyanocobalamin.
That is a mouthful. Say that again.
Cyanocobalamin.
Mm-hmm.
It contains the metal cobalt, which is why it has that name. Its deficiency causes pernicious anemia.
Pernicious anemia.
Yeah, and this isn't just regular iron deficiency anemia. It's a specific type where the red blood cells don't mature properly.
Okay, so for B complex, B1 leads to beriberi, B2 chelosis, B12 pernicious anemia. Got it. What about vitamin C?
Vitamin C, or ascorbic acid, is linked to scurvy.
Scurvy.
The classic symptom is bleeding gums. Vitamin C is essential for making collagen. And collagen is like the glue that holds your tissues together. Without it, your gums literally can't hold themselves together and they start bleeding.
That's a gruesome but very effective image. No collagen, you fall apart. Scurvy. Okay, let's switch to the fat-soluble ones. Vitamin A.
Vitamin A is retinol. Its deficiency leads to two things you must know.
Yeah.
Night blindness and xerophthalmia.
Right, and you need to distinguish them.
Yes. Night blindness is when you can't see in dim light. Xerophthalmia is more severe. It's the hardening of the cornea of the eye.
Hardening of the cornea. Okay. And vitamin D.
Vitamin D is interesting. It acts almost like a hormone. It regulates how your body absorbs calcium and phosphorus.
So without it, the calcium is useless?
Pretty much. You can eat all the calcium you want, but your bones won't absorb it. In children, this causes rickets, bone deformities like bowed legs.
And in adults?
In adults, it causes osteomalacia, soft bones and joint pain.
Rickets for kids, osteomalacia for adults. And finally, vitamin E and K.
Vitamin E deficiency is quite rare, but it can lead to fragile red blood cells. That vitamin K is the critical one for exams. It's all about blood clotting.
Ah.
Deficiency increases the time it takes for blood to clot. So if you get a cut and you lack vitamin K, you just keep bleeding.
So vitamin K is the plug. Without it, the bleeding doesn't stop. We've covered a lot. I want to circle back to that real-world story you mentioned about polished rice.
Yes, this is a classic case study. In the late 19th century, milling technology got much better.
Okay.
We figured out how to strip the brown outer husk off rice grains to make this pure white, polished rice. It looked cleaner, it stored longer.
So everyone preferred it. It seemed like a premium product.
Exactly. Right.
But
that husk, the bran, that's where almost all the thiamine vitamin B1 was. So entire populations in Asia who switched to this better modern rice suddenly started getting paralyzed. They were getting beriberi.
That is so ironic. They had plenty of food, plenty of calories from the carbs, but they had removed the spark plug.
That's it. They had the fuel, the starch, but removed the coenzyme needed to use it. It took scientists years to figure out the illness wasn't from a germ, but from a lack of something in the food.
And that discovery led to food fortification, didn't it?
Yes. Today, if you buy flour or cereal, you'll see fortified with B vitamins on the box. We are now artificially adding the spark plugs back in because we process them out.
It's chemistry solving a problem that technology created. Okay, let's wrap this up with our exam-safe rapid fire. I'm going to give you a concept. You give me the get full marks answer.
Pretty.
Concept 1, water-soluble versus fat-soluble.
Water-soluble. B complex and C, excreted in urine, need daily intake. Fat-soluble. A, D, E, K, stored in liver and fat. Risk of toxicity.
Concept 2, why are vitamins needed?
They act as coenzymes or cofactors for biological functions. They are not energy sources.
Concept 3, chemical name of vitamin B12.
Cyanocobalamin. Remember, it contains cobalt.
Concept 4, disease from vitamin D deficiency in adults.
Osteomalacia. Rickets is for children.
And concept 5, why does vitamin C decolorize KMNO?
Because vitamin C is a reducing agent and antioxidant that reduces the purple permanganate ion to a colorless manganese ion.
Brilliant. That's a solid cheat sheet for Unit 10. As we close out, I have one final thought. We talked about how we can't make these molecules ourselves.
Well, mostly. There's that one exception we mentioned, vitamin D.
Ah, right.
We're actually like solar panels. When UV light from the sun hits our skin, it converts a cholesterol derivative into vitamin D.
So we are a solar-powered hybrid factor.
In a way, yes. But for everything else, the A, the C, the B complex, you are totally reliant on your diet. The orange you eat today becomes the coenzyme helping your brain work tomorrow. You are literally built from what you eat.
That's a wild thought to leave us with. The chemistry isn't just in the textbook. It's running your metabolism right now as you're listening to this.
It is.
Students, Unit 10 is very high scoring if you are precise. So don't be vague. Use the chemical names, memorize the diseases. You've got this.
Good luck with the revision.
Keep learning, and we'll see you in the next deep dive.